Alright, hello and welcome to episode 18, I think, of my Retro City Rampage Clone in Unity tutorial. Today we are doing traffic, like civilian traffic, so they just run about. Basically cars just run about and just circle them out, just meaninglessly or randomly and whatever. So I will just show you that. So you see, cars go back around. The reason wait, that's not even the right, is it? No, American traffic would be the other way. Hold on, 1 second, sorry. Which one was that? One, two, oh shit. So you would be here. And which one was the other one? You would be there. Yeah, sorry. Trying to do an American traffic system while living in Britain is not fun. You get confused over stupid shit, but whatever. So yeah, as you can see, they reach junctions and make decisions about where to go, and they can stop when they get blocked, and all that fun stuff. As you can see, and it updates the map when they stop, so things can navigate around them. And you are, well, not updating that, updates the A-star grid, basically. When I'm not like blocking the civilians. So yeah, that is basically what it does, and now I will show you how it does it. So first off, we got two basic containers for like the arrows that you see. So the first off is the traffic direction point container, which, as convoluted as the name, is basically it stores a point A to B, which is basically just the car goes to point A, then it goes to point B, then it gets the next one, the next point, if there is one, which is just the same as does another point A to point B. If this is basically just if there's like only one direction it can go. So if we were going from this point here to, to this point here, it'd be like, that'd be B and that'd be A. So basically the red arrows would be points, the point B of a container, then the green one's at point A. Okay, and a junction container is for when we have multiple potential directions we can go, because it doesn't really matter where we go. So we just get a random number between 0 and the potential point stop length, and it returns that. So it just gets a random point that we go to. So yeah. So say we were here, we'd want to make the decision: do we go to this point or to this point? And that'd be random. So we've got these, and to like control all these, we've got them stored in a data structure called traffic points. So as you can see, we've got a traffic point here. We got the point A, which is that one, point B, which is that one, and in the parent object, we've also got those two points stored in the traffic direction container, and we've also got a junction container showing where we can go. So we can either go to this point or this point, which, as we can see, if just lock that, junction 2 is one, that is that point, and junction 4 is that point. So yeah, that's pretty much how it works. And if we don't have a junction, so which one doesn't have a junction? No shit, yeah, it's locked, isn't it? Yeah, so this one. So this just controls this point to this point, and when it reaches this point, the car reaches this point, it goes straight to this point without having to randomly choose a direction to go. Isn't that lovely? So how does it do it, you ask? Well, I will show you in a minute. So basically we just got cars, but we've added the civilian traffic AI scripts that we've got. So we've got another traffic direction point container, which was a stupid name now that I think about it, but whatever. Which is the basically current one that we're going to, and we've got a transform, which is the current point. We've got a boolean for are we going to the first point of the traffic direction container, and a boolean for should be moved, which basically controls should we be moving at all. We've got our car visuals, which we just get from the car, controls how it looks. And this is just basically to display it in a inspector so I can have a look at it to work out some bugs before, but whatever, they're gone. So starting off, we just set the point moving to the current point container dot point A. So it basically just gets the first point. You have to initialize the cars with 1 so they know where to go to begin with, which you could probably just do when we implement spawners for stuff and make the world a bit bigger rather than this little cul-de-sac or whatever. Where are we? Scripts. No, I don't want BFXR. I want this. So yeah, we've got 4 methods: update point, control movement, calculate direction, and detect obstacles. And car visuals, we got car visuals there. Simple. Control movement basically just checks if should move is true, then we basically just move in the direction of the next point, the point we're moving to. So that's just a transform, I think. Yeah, there we go. And it sets car visuals moving.true to animate it and transforms.translates. Else it'll set car visuals moving to false. I've just realised I've not got anything added from it. I have missed a bit actually. Where is NPC AI? Car AI? No, it's on the enter-car script, wouldn't it be? Sorry, I've just forgotten to say, like, just realised if someone enters it, so, sorry, I forgot to add if the value tracker might be this, that, game object, that, get component. Alright, I'm gonna see. Object, get component, civilian track AI. Dot enabled equals false. Sorry, I forgot to add that line of code there, which basically just disables it if the player gets in it, and I'm going to add the same thing for if same thing if an NPC gets in the car. Basically, probably should have like an NPC or a civilian spawn when you exit it, they get kicked out, but whatever. It does not matter. So yeah, now we go back to the civilian traffic AI. So we got another method, which is basically the same. It's calculating direction of the car, so we know what sprite to use in the car visual script. So it's similar as before. We got the point moving to dot position minus this dot transform dot position to get the direction between the 2 objects. We normalize it, which basically makes it of a magnitude of 1, I believe. So the number will be between 0 and 1 to reflect the direction in units of 1. So you can multiply it and it'll be the same direction, but like a longer line, if you get what I mean. So yeah, and then this is all the code to, now we got just set that into float what X and Y for simplicity. And yeah, so we decide to move up, move left up, etc. You know, you can see this, you can copy it all down. I don't need to explain to it. Yeah. Pardon me. Now we get on to the update point, which is the meat of it, basically. So for this, basically, this is what controls the current point we're going to, if we didn't already get that. So if the vector3 distance between, if the distance between this game object's position and the point it's going to is less than 0.1, so we've pretty much arrived at it, then we then check if we're on point A. So if we're on the first point of the current point container. Wait, so if that's the last one, sorry. If we're not on the first point, so if we're on the second point, we've reached the end of it. If the current point container doesn't have a next point, so that would imply, basically what that means is that there's a junction that are on it. So we get so basically we get the junction container, and we get a random point to go to, and so that gets assigned to the current point container. and then we set the point moving to the new current point container's point A, and we say, are we on point A to true? We've also got basically just a catch to say if there's a mistake where, say, there isn't a junction container and there isn't an next point, we just stop the car rather than errors coming up and stuff. So simple, really. Just stop it. And this is the condition for if we are on point. We are on point between point A and point B. Oh, we've just reached point A. Sorry. So it sets the current point container to next point. Oh, sorry. This is if we've reached the end of it, but it's not a junction, so we've actually got a next point. So it'll just assign the next point, the current point container, to be the current. All right. So the current point container contains a next point, and that is set to be the current point container. Sorry. And then it sets the point moving to the new current point container's point A, and then it says, are we going to point A? True. And then else, if we are moving to point A, it'll just set it to point. We'll set moving to point B and set it to false. What else? And now we've got the detect obstacles, which is basically as you can see, I'll just show you again. You see like the little turquoise raycasts that are coming off. These basically detect obstacles and stop the car when they hit it, basically. So if you saw there just that a civilian got in the way, he might get in the way. Yep, he got in the way, so he stopped. He didn't want to run over it, so he went again. And as you can see, the grid changes when they get scanned. This is basically for the... Oh god, he's going to get run over. Yeah, it's not perfect, but it sort of works. Yeah. So basically what it does is it gets the direction and normalizes it between this point and the point the direction it's going. We've got a raycast hit 2D array called hits, which is basically just all the things that the raycast will hit. And then this just basically draws a raycast in front of from the car in a direction it's going for free in-engine units. This basically just draws the raycast so you can see it in the editor. For some reason, you can't just give it a raycast. You have to draw it again, and you can't say a length. You have to multiply a direction by it, which is weird, but whatever. Basically, we're using a for each array to go through all the hits, and it'll try it just to stop it throwing errors and whatnot. So we don't need that anymore, do we? Got to fix that bug. So it checks if we've either hit the player, if the raycast has hit the player, so that'd imply that the player's in front of the car. If we've hit another car and the car is not equal to this game object, so there's another car in front of them, or that the hit collider is an NPC. So basically, if we've reached an obstacle, it will set it to false. It will stop the car moving, basically. It will find the A-star path object, which is the graph. I think there's another train coming, that'll be fun. Which is basically this script here, which controls the grid for the pathfinding of the NPCs. And it will cause that to scan. And I might just wait for the train to pass and explain what scan is. Alright, basically, scan just checks again to see where obstacles are and redraws the graph. So if I've moved that now, so if I click scan, you'll see that there's now a marked area where the things and NPCs and whatnot can't go because the vending machine's in the way. If I move that out again and scan, then they can go again. Simple. And yeah. And then it returns here, so it's it basically returns control to the call of it, so it'll go back to the update function and say, all right, we're done here, we can go back to update point. And basically what that means is that we don't need to run the rest of the loop or whatever, because we have we have Summit blocking our way, it doesn't matter. But if we get through all the hits and none of this condition is met, it basically, so say the NPC or whatever has moved out of the way and the car can continue going, it'll basically just finish looping through and get to here. So should move equals it'll set should we move equal to true. So it'll go again. It'll start moving, and I think that's it actually. Yeah, we just had to literally just add that to the new civilian traffic AI script to the traffic point container. No, we had just added that to the cars and stuff. Yeah. Sorry, just chatting gibberish. It's been a long day, and I've had a nap and stuff, and the internet's being shitty again. So that's not fun. But yeah, this is just the traffic that you learnt to program. Although it is a little glitchy for cars colliding with each other. Maybe that needs to be worked on. And you'll just what doesn't matter. Yeah, you may see little graphical glitches where the cars don't use diagonally when they should. That's just because the placement of the points that mark it out. Because they're not yeah. If you're careful with the placement, it should work fine. It's down to the points, not the actual code. Yeah. Although sometimes there are glitches like the civilians walking on the road because their deck's like that. But whatever, maybe you could remove the condition and just have them get run the fuck over. Not my job. Yeah, cool, not mine. He's walking out into an intersection. Run, little boy, run. So yeah, that was traffic AI. Just for watching, comment, subscribe, and I think 4 people have bought my asset pack for Hotline Miami, so that's good. If you haven't done, do it. It's really good. Or you could just copy the code from the tutorial series and make your own art and whatnot. Play loud or quiet, that's really good. I've had a load of downloads actually in the past couple of days, and hopefully my internet will get better because I thought it got better. Cancelled the engineer and then it decides to get fucking worse again because life is a bitch. Whatever. Bye.